This is a solution video to question 18, paper 2 from the TMUA 2020 exam. So the question here is about two cubics, f of x and g of x. They are general cubics with coefficients a, b, c, d, and p, q, r, s. And then we're told that f of x minus g of x is positive for all x, and then we're asked which of the following three statements must be true, essentially. The first one saying a is bigger than p, so this coefficient is bigger than this one. The second one saying if b equals q, so if this guy is equal to this guy, then c must be equal to r. And the third statement is saying d must be bigger than s. So the first thing you want to do is you probably want to think about, okay, so what does this condition mean? When can this be true? So first note that the f of x minus g of x is the difference of two cubics. So if it's a difference of two cubics, then we might think that it is a cubic and it looks something like one of those two graphs, right? This is just the two possible shapes that a cubic could have. But in either case, we can see that the cubic will cross the x-axis. So that means that f of x minus g of x cannot be always positive if f of x minus g of x is a cubic. So that means f of x minus g of x is not a cubic. Therefore, it must be a quadratic or a linear thing or a constant. So if it's not a cubic, then that means that a must be actually equal to p. So we know a equals to p. That way, when we take the difference, the cubic terms cancel out and we just left up with a quadratic. So that means a is not bigger than p, so 1 is false. Next, we're thinking about the case where b equals q. Well, if b equals q now, then f of x minus g of x is going to be linear because we know that a is equal to p, so a and p cancel out. So if b equals q, that means this term and this term also cancel out. So all we're left with is cx minus rx and then d minus s. But that's also a linear thing, that's a line. But a line always crosses the x-axis, so that means this also won't be true unless c is equal to r. So that means 2 is definitely true. And finally, if we're looking at the third case, we're trying to compare d and s. So we're trying to compare d and s in f and g. So it makes sense to try and eliminate everything before that. So if we try and do that, then we need to set x equal to 0. So if we set x equal to 0, then all of these things here would cancel out, and then we'll be able to compare just what d and s are. So we know then f of 0 minus g of 0 is positive, but f of 0, so that means f of 0 is greater than g of 0, but f of 0 is d, and g of 0 is s. So that means d is greater than s, so this is also true. That means our answer is G.